Last week, we talked about how to display categorical data, bar charts and pie charts specifically. We also talked about how pictograms are not an effective way to display data. Today, we're going to start discussing quantitative data and the way that we display quantitative data that involves numbers. So we're going to be talking about, over the next couple of days, dot plots, stem plots, histograms, and box plots. In this video, we're going to focus on dot plots. So it's really important to note that the way that we analyze data depends on the type of data set you're trying to analyze. So if we're analyzing categorical data, we approach it one way. If we're analyzing quantitative data, we're approaching it another way. So one of the simplest graphs that we use in statistics is called a dot plot, and you will see this very, very frequently. And it's a great type of visual representation of data because it very clearly allows us to get a sense of what the data look like. So we'll talk about that a little bit later, but let's first talk about how we make dot plots. So in a dot plot, each data value is represented by a single dot plotted above its location on a number line. So how do we make a dot plot? We draw a horizontal axis and label it with a variable name. This is what we're trying to measure. In this case, it's the number of goals scored. We scale the axis from a minimum value to a maximum value. There's no right or wrong scale as long as you make it clear in your diagram. And finally, we mark a dot above the location on the horizontal axis corresponding to each data value. So here's the data set that this dot plot came from. Notice that the smallest number is 0. So that was the minimum value on my axis. The maximum value is 14, so that was the largest number. And then for each data set, I put each data point, I put one dot above the corresponding location. So when I said there was a 2, I put a dot above the 2. A 1, I put a dot above the 1. 5, a dot above the 5, etc. So go ahead and jump in and you try this right away. Pause this video, read the prompt, and make a dot plot to display the data shown below. Nice job. Compare your dot plot to mine. Notice that I abbreviated highway miles per gallon. This was a computer output, and that's why it did this. Go ahead and correct your work against this. So the purpose of making a dot plot to represent data is to help us understand the data and to help us see what it looks like. So when we get a data set, we always are going to represent it graphically. And then after we make the graph, we're going to ask ourselves the question, what do I see? So you are going to be asked often to describe a distribution of data. And when you're asked to describe a distribution of data, we are looking for 4 things for you to describe. So in any graph, you're looking for the overall pattern and for striking departures from that pattern. So we describe the overall pattern of a distribution by its shape, its center, its spread, and then the outliers are the departures from the pattern. Those are individual values that fall outside of the overall pattern of data. So we have a funny little mnemonic to remember this, which is SOCS. Shape, outlier, center, spread. So anytime you are asked to describe a distribution of data, particularly quantitative data, you are going to use SOCS to describe that distribution. We're now going to look at a video. Now we're going to watch a video of the example on page 26 of your textbook. Feel free to follow along as the textbook publisher discusses how to do this example. You'll recognize the data set as you've already made a dot plot of it in the previous slides.
Hi, this is Jason Molesky. In this example, we'll take a look at how to interpret a dot plot. The Environmental Protection Agency, or EPA, is in charge of determining and reporting fuel economy ratings for cars. For years, consumers complained that their actual gas mileages were noticeably lower than the values reported by the EPA. This table displays the EPA estimates of highway gas mileage in miles per gallon for a sample of 24 model year cars. Let's take a look at a dot plot of the data. When looking at a dot plot, what we'll want to do is describe the shape, center, and spread of the distribution, and comment on whether or not there are any outliers. Recall that in a dot plot, Each dot represents a different observed value within the data set. In this dot plot, we can see that the shape has a peak at about 30 miles per gallon and a main cluster of values from 23 to 34 miles per gallon. We see there are large gaps between 18 and 23, between 34 and 40, and between 40 and 48 miles per gallon. The midpoint of the 24 values shown in the graph is 28. So a typical model year 2012 midsize car in this sample got about 28 miles per gallon on the highway. For the spread, we notice that the data vary from 18 miles per gallon for the lowest gas mileage to 48 miles per gallon for the highest. And in terms of outliers, we see that two midsize cars have unusually high gas mileage ratings. The Hyundai Elantra at 40 miles per gallon and the Toyota Prius at 48 miles per gallon. These values seem like clear outliers. The Bentley stands out as a possible outlier for its low gas mileage rating of 18 miles per gallon. For additional practice with interpreting a dot plot, try exercise 39.
So our friend from the textbook just discussed shape, outlier, center, and spread. We're going to be focusing today especially on describing shape. We will get to the other ones, but right now we're going to talk about them in less specific terms. We'll be working on those over the next couple of days. So when you describe a distribution shape, concentrate on the main features, which are symmetry or skewness. So a distribution is roughly symmetric if the left and right sides of the graph are approximately mirror images of each other. So here's a dot plot of some dice rolls, and you can see that this is approximately symmetric. You have seen this before in Algebra 2, and we never describe a distribution as being definitely symmetric. No real world data is perfectly symmetric. So whenever we're discussing curves and symmetry, we always have to talk about them being roughly symmetric or approximately symmetric. We say that a distribution is skewed to the right, right skewed, that's this one, if the right side of the graph, or the tail, is much longer than the left. So you see we have a cluster of data values over here on the left side of the graph, and then fewer over to the right. Similarly, if a distribution is left skewed, the left side of the graph, or the tail, is much longer than the right side. This can be a little bit challenging to remember, so I have a silly way for you to remember these. So remember that the direction of skewness is the direction of the long tail, not where most observations are clustered, right? We talked about that here. Left skewed, long left tail. Right skewed, long right tail. So a funny way to remember this is that your right foot looks like a right skewed distribution, right? Your big toe is the big cluster of values, and your other little baby toes are where the tail is. And similarly, with a graph that is left skewed, your left big toe is where the cluster of values are, and then we get our tail off to our smaller little baby toes. You'll notice that there were some other ways that our textbook friend described shape. So in addition to describing symmetry and skew, we can also talk about peaks in the graph, or modes. You remember that word mode from middle school? The mode of a data set is the value that shows up the most frequently. So here we could say there's a peak at 100, or the mode is 100. These dot plots don't have context. We're just using them to examine shape. Notice he also talked about clusters and gaps in the data. Right here we have clusters of values between 64 and 72, and between 94 and 93 and about 97, something like that, with some gaps here in the middle. Additionally, we can talk about dot plots in terms of how many peaks they have. When a dot plot has one peak, we say that it is unimodal. There's only one mode, one value that shows up most frequently, in this case 55. When a dot plot is bimodal, it has two modes here, 25 and 40. If a dot plot has more than two modes, we just call it multimodal. And finally, we sometimes see a uniform distribution. A uniform distribution is where all values are approximately the same. So now, using what you learned in the video, try the Check Your Understanding questions from page 29 in your book and check your answers against the key at the back of the book. Pause the video right now and go ahead and do that. So now you've gotten a little bit of practice describing shape, center, spread, and outliers for one data set, but some of the most interesting statistics questions involve comparing two or more groups. So when we're asked to do this, we're always going to discuss our SOCS, shape, center, spread, and outliers for both data sets when we compare two sets of quantitative data. So we're now going to look at an example from the textbook publisher about household size in the UK versus in South Africa. Feel free to follow along on page 30 of your textbook to see where this example comes from.
Hi, this is Jason Molesky. In this example, we'll take a look at comparing distributions. How do the numbers of people living in households in the UK and South Africa compare? To help answer this question, the authors used Census at School's random data selector to choose 50 students from each country. This dot plot displays the household size for these two random samples. When comparing two distributions of quantitative variables, we want to make sure we discuss the shape, center, spread, and note whether or not there are any outliers for both distributions. In looking at the shapes, we see that the distribution of household size for the United Kingdom sample is roughly symmetric and unimodal, while the distribution for South Africa is skewed to the right and unimodal. In comparing the centers, we see that the household sizes for the South African students tended to be larger than those for the UK students. More specifically, the midpoints of the household sizes for the two groups are 6 people and 4 people respectively.
A quick note on how he found the midpoint of each of these. So you can count the total number of data points, and the midpoint is the one in the middle. So let's say there were 50 data points and I wanted to find the midpoint. I would count out 1, 2, 3, 4, 5, 6, 7, until I got to 25. That 25 would be my midpoint.
In comparing spread, we see the household sizes for the South African students varied quite a bit more, from 3 to 26 people, than they did for the UK students, which only ranged from 2 to 6 people. And in looking for outliers, we note that there don't appear to be any outliers in the UK distribution. On the other hand, the South African distribution seems to have 2 possible outliers in the right tail, students who reported having 15 and 26 people in their household. For additional practice in comparing distributions, try exercise 43.